Hello guys, welcome back to my channel. If this is your first time, then still welcome. This is Leetcode 980, unique part 3. One of my favorite questions. Um, and it's recently been asked by Amazon, Google, Facebook, Line Bike, Adobe Pinterest, and so on and so forth. Right? Cruise animation. So this question seems to be very popular, right? And it is a legal hard question. So, you know, there are like a few limitations with the question, right? But basically, you are given an n by n grade, right? Where there are four possible numbers, right? The grade could have one, right, which is the starting square where the robot is standing, right, and then you have two where that's the ending square, right, where you're gonna get to. Zero means you can you can walk through that square, right, and then negative one means there's an obstacle, so you cannot walk through an obstacle. And the question is actually to return all the number of four directional walks, right? So moving up, down, left, and right, where you can move from the starting square to the ending square. And not only that, but you move through every single non-obstacle or every single zero square, basically, at least once. Cool. So basically, we if you want to move, right, we want to move through all the squares. So we have one, two, sorry, all the zero or empty squares. Right? So you move through this basically. So the robot will start here. Possible path is he moves through here, comes here again, and reaches his goal, or finds a different way of passing through all of them essentially. So I can go this way, and then yeah. So that is what these mean. And here he has like multiple routes. He can go four different routes. Um, and here there is no path, right? I say there's no path because he can't walk all over all of them once. Right? Like if he goes here, he's gonna come here, right? He can't right. I mean, I would have thought maybe come here and this, but it says there is no path that walks over every empty space exactly once. Know that the starting and ending points can be anywhere in the grid, right? So the fact that the starting and ending points are, could be anywhere. We have to find the starting and ending points ourselves, and then do the work from there. So, cool. Basically, how are we going to approach this question? Well, essentially, we are looking for all the possible number of four directional ways, right? So if you are thinking about it, should be a backtracking question, right? Because when I say all possible A, B, C, D, right, it should be backtracking. And also the constraints, right, are a good giveaway, right? We have M and N being between 1 and 20, right? Just usually we have like tens of thousands of um, the whatever the constraint is, but here it's very small. So it shows you that it is a backtracking problem, right? So you can use backtracking in DFS basically, and that's what I'll essentially be doing, right? So I want to keep a few variables. Right? I want to keep int m and int right n, right? Use the length of the rows and columns basically, right? And then from there, what we want to do is to know the number of zeros we have, and oh, sorry, the number of zeros we have, right? And then also, I want to keep track of our possible starting positions, right? So my possible starting position for x and for y, right? Because we do not know where they are. So basically, we have to go through the grain. So if I is equal to, right, and so why am I using the dark mode? Well, basically, I just want to switch things up, right? Because I initially started like coding these kind of questions with the dark mode. I hope you guys like it. If anything, let me know. Give me some feedback, right? So if the grade element, right, grade ij, if that is equal to zero, right, then we increase our zeros, right? So we've seen a zero, we increase our zeros. Else if, right, because we are interested in only the start and the end, sorry, in the start and the zeros right now. So else if it's equal to 1, right, that's a starting position. So then my x becomes what I now, and basically my y becomes what tj, right? So when we go through every element, right, then what we want to do is return and have a DFS method, right, which will return the total total correct paths basically, right, that we found. Yeah. So what will our DFS take, right? Well, excuse me. What else our DFS take, right? It takes what the grade. We'll have the grade in there. Also, I want what the number of zeros we are dealing with. I want our starting and ending positions, right? So, sorry, our starting position, the coordinates for our starting position, which is x and y. And also, I want, let me think. We also probably want a visited array, right? So a new Boolean array of m and n. Basically, because the visited array will just help us like avoid repetitions and stuff like that. Cool. Right. Cool. We have everything I think we need. If not, we come back to our DFS. And let me leave space so I can. Okay. Cool. So we have a grade, right? I think it's an integrated. Yeah, cool. It's a grade, and we have a number of zeros. Sorry, x and y, and then Boolean, Boolean matrix called visited, right? So what are we gonna do with our BFS? Sorry, our DFX, DFS. Well, we will first like make room for listen, edge cases, right? Like if everything goes out of bounds and so on and so forth, right? Or when we hit an obstacle, right? So we want to write for those edge cases. So if our x is less than 0, or our y is less than 0, or our x is equal to greater than, or our y is greater or equal to what? Grade 0 dot length, or we previously visited the node, right? Sorry, visited XY, and actually even before we check if it's visited, we want to check if it's an obstacle. Okay, so basically, we want to grade XY. Sorry, guys, typing. So if grade XY is equal to a -1, or we visited it, if we have, right, then what we want to do is what return 0, right? That's not a valid path, basically. So return 0. But what is a valid path? Well, basically, if our grade of our I and our grade of our x and y is equal to 2, right? It means we have reached what the what is it called again? The ending square, right? So when we reach the ending square, what we want to do now is to check, right, if a number of zeros, right? And as we every time we see a zero, right, we decrease our count of zeros basically, right? So if our zero is equal to 0, right, then we return 1, basically, right? We return 1 because, mind you, it is an int, um, it's an int function, right? We return 1 whenever we see a valid path, because we return 1 because what we have seen a valid path, basically, right? And else, we return what's so else we return 0, right? Like the path wasn't helpful, basically, right? So what we want to now check is now do our normal traversal, right? So if the grade xy is equal to 0, right, then we'll decrease our number of zeros, right? So as I was saying, like every 0 we see, we decrease. And then I want to keep an int of called total, and total is going to be DFS in all 4 possible directions, right? So it's going to be we're going to take grade, we're going to have zeros, right, and then it's going to be what basically x minus 1, right, y, and then a visited. Also, yeah, and visited basically, right? Plus DFS of the grade, the zeros, right? All for possible directions. So x also plus 1, y visited, what, plus DFS in the grid, sorry, zeros, x, I'm not changing here, but y now changing, and for the visited, and then plus what, BFS for the grid, zeros, x, y plus 1, and then the visited. And then actually just before we do this, right, what we wanted to do is also say that for our current position x, y, right, we've already visited it. So if you have visited that part, we say what? We set it to true, right? Once we set it to true, we find this variable basically total, which is going to give us our DFS in all four directions, right? And after that, we give ourselves the opportunity to backtrack by having what visited XY, where we revert it to false. And if it backtracks, then fine. If the whole DFS is done, right, then it should return what total, right? That's what I want. Excuse a bit another word as well. Excuse me, guys, but the basically this is how the DFS is going to be, right? Edge cases, and then if we hit a 2, right, then we return a 1, else the part was not valid, we return 0. And whenever we see a 0, we reduce the grid, and then we do our backtracking from there on. What I want to do is now run the code. All right. And then I want to submit, right? Right, so it passed 100% of Java users. It's awesome. I hope you guys enjoyed the video. Try and leave a link to the code in the description. But hey, this video should be helpful, I hope. And guys, I'll see you guys on the next one. Peace.